Well, hello, this is Unit 4, Video 10, and we're going to work on solving some different types of equations. They're all going to have a common theme with the exponents and needing to change them around, but I'm going to give you a couple strategies that you can use as you approach them. But please keep in mind that the strategies I'm offering you here can be applied to other problems, but they may need to be altered slightly. So that's part of your responsibility, is to figure out just exactly how to apply them and when to apply them to different equations. So the first one, we're going to go ahead and use a u substitution here. And this is something we've kind of looked at before. It's not completely unfamiliar to you. So we're going to start by just suggesting that if x to the fourth really equals x squared squared, then we're going to let u equal x squared. So in this case, I would end up with x to the fourth would really be a u squared because I'd replace the u inside. So I'm going to have 4u squared minus 8u, because the x squared is a u, plus 3 equals 0. You can use whichever method you like at this point to factor it. I'm going to go ahead and use the split the middle, that kind of grouping method. So I'm going to multiply 4 times 3 to give me 12. And I know that negative 6 and negative 2 multiply to a positive 12 and add up to a negative 8 for the middle. So that's going to give me 4u squared minus 6u minus 2u plus 3 still equals 0. I'm going to factor by grouping by factoring out a 2u minus 3. Here I'm going to factor out a negative 1, giving me 2u minus 3, still equals to 0. I'm going to go ahead and continue factoring with a 2u minus 1 and 2u minus 3. So we're completely factored now, and now the solving begins. So if I set each of these equal to 0 and I solve for u for both parts, I end up with u equaling a positive 1/2 and u equaling 3/2. But before I decide this problem's done, I've got some solutions, I have to remember that this was a u substitution and that my original variable was x, and u is just a representation of x squared. So I'm going to now replace that u with the x squared that we established in the beginning, and I'm left with having to solve two smaller equations now. So x squared equals 3 over 2. So to solve these, I'm going to use the square root method by taking the square root of both sides, giving me x equals positive and negative, the square root of 1/2, which is the square root of 1, over the square root of 2, which I will rationalize for a final answer of positive or negative root 2 over 2. On the other side, very similarly, we'll take the square root of both sides and get x equals plus or minus the square root of 3 over the square root of 2, which will also be rationalized by multiplying both the numerator and the denominator by the square root of 2 to be square root of 6 over 2. To check these answers, you can substitute them back in using the calculator, using parentheses around the entire thing. I'll show you just one side of this. That would be 4. And I'm going to substitute in the square root of 2 over 2 to the fourth minus 8 times the square root of 2 over 2 squared plus 3. And my hope is that that equals 0. Please note that when you're raising something to an even power, I don't have to check both the positive and the negative because the even power will take care of eliminating the negative if I were to check that one. So really I'm only checking 2 of these 4 answers. So this right here, if you go ahead and type that in your calculator, you will see that it does equal 0 and that all of my answers will check out. So my solution set here is plus or minus 2 root 2 and plus or minus the square root of 6 over 2. I might have said that wrong, the square root of 2 over 2. The brackets that I'm using here is not an interval notation. It's actually a solution set notation, kind of like a set builder, so we use those squiggly brackets. I got a couple more. Let's keep going. Okay, for this one, a different strategy. For this one, I have these rational exponents on a quantity on both sides. And the strategy I'm going to use here is I'm actually going to raise them both to the same power on both sides. Because if I square both sides or cube both sides, then I'm actually using a valid method for solving an equation. In this case, I'm going to raise both sides to the fifth power. I'm choosing the fifth power because that will actually, with my exponent properties, reduce my exponents here. So I'd get 10 fifths, or just 2. So this would be x minus 3 squared. And on this side, I would just end up with 4x. Okay, so need to continue to solve this. And the best way to do that is to go ahead and multiply out this side. And this is going to become x squared minus 6x plus 9 still equals 4x. We'll subtract over the 4x. Negative 10x plus 9 now equals 0. And then we can factor. This should be a fairly simple one to factor. X minus 9 and x minus 1 still equals 0. X will equal positive 9. X will equal 1. These are the answers I'm looking for. I don't have to substitute anything back in, but it is always good to check your solutions by substituting them back into the original. In this case, both of them check out, and my solution set is 1 and 9. For my third example, I'm going to go back to this idea of u substitution, but it's a completely different look to the problem because I have these rational exponents. All right, so what we're going to do is I'm going to suggest here that since, I'm going to write it up here at top because that was kind of long, since x plus 1 to the 2/3 power will really equal x plus 1 to the 1/3 squared, using my exponent properties because of the multiplication there, that we can let u equal x plus 1 to the 1/3. Therefore, I'd end up with a u squared if I substituted that in. And that's just what we're going to do. So I'm going to have u squared minus u minus 2 equals 0, because my u equals this x plus 1 to the 1/3. So this whole thing becomes u, and this whole thing becomes u squared. That looks really simple to factor, and it is. So we get u minus 2, u plus 1. I get u to equal positive 2 and u to equal negative 1 when we set each of those equal to 0 using the zero product property. And now I have to go back and use that substitution idea. So I'm going to set x plus 1 to the 1/3 power equal to 2. And then I have x plus 1 to the 1/3 power equal to negative 1. I'm going to combine ideas here because now in order to get rid of this cube root, or excuse me, to get rid of this 1/3 power, I'm going to use a cube. So I'm going to cube both sides. So I'm going to change colors. I've got so much going on here that I'd like you to see this one very carefully here. So I'm actually going to raise both sides to the 3rd power. And this next step will just be an x plus 1 equals 8. Over here, x plus 1 equals a negative 1, because negative 1 cubed is still negative 1. I'm going to end up here with x equals 7, and on this side, x equals negative 2. Now, where do you check your answers? You always check your answers back into the original problem. So make sure you do that before you decide that this works or doesn't work. And my solution set is negative 2, 7. I got one last one to try with you. Okay, again, we're going to use a u substitution for this problem. In this case, I'm going to let x to the negative 1. That's going to be my u. Okay, so again, I'll end up with since it's a negative 1, this will be a u squared. So 6u squared plus a u. Oops, I forgot to subtract this 2 to the other side. So that step would definitely have to happen before our substitution or in the next step following the substitution. It looks like we're ready to factor this. You can go ahead and multiply and use the split the middle grouping method if you'd like, or you can factor another way. This time I'm going to use 4 and negative 3. So I've got 6u squared plus 4u minus 3u minus 2 equals 0. Factoring out a GCF gives me a 3u plus 2. Factoring out a negative 1 is a 3u plus 2. So 2u minus 1 and 3u plus 2 equals 0. When we set those equal to 0 using the zero product property, we end up with u equals a positive 1/2 and u equals a negative 2/3. Okay, so we have to go back and remember we're using our u substitution, which means we have to substitute back the original expression. So since u equals x to the negative first, and over here u equals, x to the negative first equals negative 2/3. Okay. So how do we handle that? Well, if x to the negative 1 first is actually the reciprocal of x, in other words, it's 1 over x equals 1 over 2, then just by looking at this, maybe even investigation, we can see that x has to equal a positive 2. On this side, 1 over x equals negative 2 over 3. You can use cross multiplications if you prefer, or if you just recognize that this is really representing the reciprocal, 1 over x is the reciprocal of x, then x must be negative 3 over 2. Again, you can check your answers by substituting them back into the original and using your calculator to verify. And we have here that x equals a negative 3 over 2 and a positive 2. I'll use them in my solution set notation here, and I've completed them. So as you give these problems a try here, and there's not too many, just 4 for you to try for homework, looking at 61, 63, 65, and 67, you're going to be using the u substitution and the idea of raising both sides to the power, to the same power. So taking those ideas, please make sure you attempt these 4 problems and that you bring any questions you have to class. In class tomorrow, we'll continue through some more of the little more challenging problems that may just take a little bit more time to set up and approach. So good luck, and I'll see you tomorrow in class.